And good evening, everybody. Welcome back into the Dragon's Den. My name's Sigil Dragon. I'm a 3D printing variety streamer over on Twitch and YouTube. Hey there, Icarus Lynx. How's it going? KB3D Chris too. How's it going, Chris? You wholesome dude, you. Hope you're doing well. Long time no see. Yes, Chris too was at Murph. They were in if you came in through the main entrance into the venue, they were the back right-hand corner, all the way shoved up in the corner. And I was basically on the inside corner facing them. And if on one side, I was looking straight across to Kadivi plates, and then right into the corner, we had KB3D. English cripple with the walker. Quite possible. Yeah, quite possible, quite possible. I'll be honest with you. I've done those two shows, and I do monthly maker meetups out at the local 3D printing store here in Raleigh, North Carolina. And I see so many people, and it takes me like 2, 3, 4 times before I start putting, names to faces and stuff a lot of times. Hey, Eagle the Dragon, how are you doing? Mrs. Dragon is doing good. I believe she's down on some type of call, conference, whatever. And my day at work was okay. I did go to the office for a little while, had an all hands I had to go to, stopped by Ecovate, the 3D printing store I was just referring to. They've got a killer taco truck that's right in the parking lot next to them. So I grabbed one of the guys there at Ecovate. We walked over and grabbed, I was going to grab tacos. I decided last minute to get an asada burrito, and I can only eat half of it at a time, and I'm still feeling it. So, and by feeling it, just full, beyond full. So I got the other half downstairs. I might eat later on today, but yeah, good stuff. And then came home and worked from home the rest of the day. You're friends with Jeremy and Keela. I was going to say I'm sorry, but yeah, no, that's good. You had an epidural in your back today. Oof. Well, I hope you get some relief. I've had so at the ripe old age of 36. Okay, I had major neck surgery, so I've had was it C4, C5 replaced, C5, C6 fused together in my neck, and then torn labrum, rotator cuff, and bicep tendon. Yeah, I've been tore up, so I know how that goes with trigger point injections and all other types of weirdness. It's not fun, so I hope you feel better, and I hope it helps relieve some of the pain and stuff. So tonight's going to be a little bit, we're going to start that shift, right? I'm not sure if you can hear some things in the background or not, but the 0G that we have been working on, she is up and running. I do have the doors closed right now because we're printing ABS. Okay. The first print that we had started on stream on Tuesday was this. This is a Cyberrook printed at 200% on the printer here. This is EPAX Fast PLA and Cosmic Plum, I believe it was. Beautiful color, nice and shimmery. The first layer, not the best right there. And I'm going to chalk it up to just a build plate, because as soon as I started to run this print, it delammed pretty bad. So I let things cool back down. I took that build plate downstairs, washed it with Dawn Power Wash, got it all cleaned up, brought it back in here, and here's the key. Let this chamber heat soak. Don't do like a bamboo and just say print, let it come up to temp, and then it starts doing its thing. This has a beacon probe in it, and we're using beacon contact for nozzle probing. So one, make sure that you clean off your nozzle before you get started. I will try and figure out a way of putting a nozzle brush in here and getting that macro set up. But I've turned on the bed and turned the, did a home so it's right close to the bed. Put the hot end at 150, did the bed at 105, and then let it heat soak for like a half hour. Then go ahead and start a ABS print, because what it's actually going to do is allow that beacon probe to get up to temp and be able to do a good temp offset when it does the first layer offset. And so we will use beacon contact, which is the nozzle probe for homing, and then it'll use that also to do the Z-tilt. It'll home again, and then it comes up to the front here, finishes its warm up, and then does a mesh, right? And it just runs the big S shape to do the mesh, and then it starts to print. Now the print that I'm doing right now is almost full front to back edge of the build plate, because I'm doing skirts for the riff over here. I'm doing the rear skirts for the riff back here, and it's just two very long skirt pieces. So hopefully we can get back over on this soon. I've got some teaser files that I can use, but we'll be getting back to this somewhat soon. I may do some of this off stream or do it over on YouTube stream or something. I don't know. But today, the plan is Jabberwocky. Oh, and one other thing. I would show you, but I've actually got them installed. I did get the 2 nightlight on a stick XXL from what, 1440 Lab. I got them from XR Bunker. So they're physically mounted. The wire you see up here is me getting wire ready. I'm going to create the connectors, and then tomorrow, once this print's done and this thing cools off, I'll be able to take the back panel off, plug in, route the wires down through the same channel that we've been using. I'll put channel covers on and pull the deck panel up, and these are the nightstick, nightlight on a sticks are 24 volt. So I need a 24 volt and ground. It's 2-pin. And, well, wouldn't you know it, there are 2 always on fan ports along the row where your motors go, right? So I'm going to plug one side into each one, and they're going to be always on UV lights in here. And if I think I need more, I will go and get another set, and I'll mount it underneath the Y rails. So I'll have one at the top and one at the Y rails, which will be about right here, to point down and light up the lower part of the chamber. So we're going to see. I should be able to run both of those no problems through that fan output, because I don't think LEDs are going to pull too much power. You have a completely torn left rotator cuff, right torn, and labrum. Yep. So the neck and my right labrum was done while I was active duty Air Force, and the right labrum was torn so bad that it was almost torn completely in half by the time we got that checked out. The neck surgery was done while I was in Germany. I came back stateside, and as I was going through my med board, I found this in my documented in my records, so I had this done right before I got out. This one was a little bit later. This was a few years ago. We were working, we have a shed out back that's 14 feet by 20 feet, and we've insulated all of the walls, and we started insulating the ceiling, and we're covering we've got the walls all covered. We were starting to cover the ceiling with 3/4 inch OSB. And I was sitting up on the loft on my back using my feet to hold up the board as I was getting ready to start screwing a couple of screws in to anchor it. And my wife was losing her grip on the other side, because it's a 4 foot by 8 foot sheet of 3/4 inch. And she started slipping down off the ladder. And so I quickly reached up and grabbed hold of that board left-handed and did one of these numbers, holding up a full sheet of plywood with my left hand, which is not my strong hand. This is my strong hand. So, yeah, there was a rotator cuff, a labrum, and a bicep tendon tear. Highly not recommended. I'll put it that way. Hey, Jedi Spidey, how's it going? You love a room filled like the problem is there's too much in this room right now. So yesterday, I keep saying I'm trying to get organized. We just got all these bins, right? And so I've got let's see, displays. Raspberry Pis and other host controllers. Controller boards. I'll say a little bit non-standard. So this will be our Duet, our Lurge board. Toolhead boards are, this is like almost entirely Nitehawk, either Stealth Burner or Nitehawk-36s. There's an Orbitool over on this side, and the whole bottom is all power supplies. So I'm trying to start getting sorted a little bit more, just big bending it right now over here. And then I've got all of my little screw holders and stuff like that that'll come over here onto the side or somewhere else. And I'm just trying to get organized. I got stuff everywhere. It's a disaster in here. And at least if I can get it big bend like this, I at least will know where to go looking for stuff. Yeah, it is. Yeah, it is heavy, isn't it? Trying to get SSDI, 5 years trying. Yeah, that's rough. You'll give me an address. I got several people that will gladly take a printer or two. However, some of the printers behind me, like this is my 300 size IDEX. This is the first kit build, black belt or black box. This one can go nowhere. This KB3D gave me this printer, and then I bought all my tool heads for it to build and test out as the beta tester for the kit. This is the only black stack that I'm aware of in existence because he still hasn't finished the CAD for it. And black stack is just a rolling cart that the printer sits on, and it has a E-dry cabinet down there that sits at like 1% humidity. So all my engineering filaments and TPUs go down there. But yeah. Chris with a K, yeah. Not finishing projects, never. Exactly. He starts and then he moves on. Okay, and talking about starting projects, what you see here is the box that the Jabberwocky toolhead. This is a toolhead that is specifically designed for multicolor printing, right? Yeah, soon, trademark. We never give a date, but oh, you didn't squirrel me, I squirrel myself. But this is the Jabberwocky, and right here are all the 3D printed parts lined up along the top here. We've got a gray, a black, and this nice blue. And you're going to ask me what the colors are. This is just a straight, I believe that's a bamboo ASA black. And my other colors are, as soon as I can figure it out, ambrosia, galactic gray, and the blue is also an ambrosia, and that is the midnight meteorite. Galaxy or galactic midnight meteorite. So I say blue, I think the galactic meteorite isn't that a purple? I don't know. I don't know. I have a hard time with purple and blues. Hey, Free Heathen, how you doing? It's Mr. Wholesome. Yep, welcome in. So this is what we're going to be building today is the Jabberwocky. Let me go ahead and bring up the full display here. And it's been engineered to meet the demanding requirements of filament changing units and multicolor changers. This extruder is purpose-built to handle the rigorous load of unloading cycles of filament changing units. It utilizes a Bondtech compound drive gear and an offset configuration with an LDO non-threaded orbiter gears for precise and reliable filament control. A lot of words there. It'll have a very constrained path and be very good. Carefully optimized balance of torque and speed, which will help a lot when you're doing long filament pulls. And designed for maximum reliability and serviceability. Features a tool-free hinged extruder mechanism, so you'll be able to take the extruder on and off really easily. You finished your pip truck. It's epic. Sweet. Yeah, so high static pressure fans. Yeah. So these kits, if we're looking over here at KB3D, the kits are about $139.99, but if this is picked up on me, then it's already got my discount. It's about $140 to $150. And this is the DIY, not assembled. The complete assembly would be $155 to $160. So, sweet. So this is a print in place that you designed, right, Free Heathen? If so, drop your link for that design out there. But as you can see, this is a pretty nice, neat little print. And you know what? I just realized that I still never found the clear parts to this, so we might have an issue when we get near to getting done, because I'm not going to have the clear diffuser pieces. The site, the GitHub for the Jabberwocky, they do have a instruction and a wiki here. And that's what we're going to work on, or work off of, is the wiki here when we go through and do our build. It does talk about having a full CAD design in here, so you might want to pull that down just in case we need it. We'll go ahead and pull that step file down so we can reference it. Oh, cool. Do you have any pictures of a printed one? If you do, feel free to post it in the Discord or post a link up to your Discord where there's a picture that you may have. Heck. Yeah, I might have to try and get those clear parts printed real fast. I think there's a big diffuser right here at the front, and it might be. Okay, so here is our Jabberwocky. Now, it does have the tool board. The Nitehawk board does come in it. So we do have the Nitehawk-36 board. And then we've got the Jabberwocky parts kit itself. Hey, Petty Ruxpin, welcome in. You saw the coffee and lube shirt and you have concerns? Why do you have concerns? I mean, we do that on stream, right? We lube a lot of balls and rods on stream. You got to lube your ball bearings and your linear rods and rails, right? But this does come with the Nitehawk board already as a full package. And once again, these were designed to be used with things like box turtle and Rage Rabbit carrot feeder, the whole 9 yards. So this is what we will be digging through today. This comes with the hot end and everything we're going to need. So we'll have the CAD up here if we need it as we go. And we'll come back over here to the wiki. And once again, we're going to work through the wiki. Printed parts, they did have the set here. They recommend printing in ABS or ASA. 0.4 nozzle, translucent material for the LED diffuser. ABS or ASA, use only high quality filament. Do not use plus filament, right? Do not use an ABS or ASA plus because they add a bunch of additives to make it easier to print, and those additives will cause you issues. All right. How are you doing today, Petty? 0.2 layer height, 25 to 40% gyroid, rectilinear grid, honeycomb infill. I personally love cubic or quarter cubic. I believe I did switch over to gyroid just for this. The gyroid pattern to me induces a lot of harmonics into the frame that doesn't need to be there. That's why I tend to stay away from it. Cool. Cool. We'll look at it in a little bit, buddy. Or actually, I normally don't pull Discord up, but we will pull Discord up. All right, here we go. I'm super proud of this. It's your first print in place toy. That's good photo there. You got it in nice and close. It's nice clean print. Got to have the Free Heathen Workshop logo on there. And once again, all of this was designed in Tinkercad, correct, Free Heathen? Oh, I like this. You get your rear lights up here, and I'm assuming these are your tailpipes popping out in the lower edge. I'm wanting you to do printer things that are going to cost you money. Dude, every time I see you, there's a new printer that I take home. Yeah, these conical wheel shapes comes down to basically like a shaft or an axle right between here. Very nice. Very nice. That looks cool, my dude. If you send it to me, I will print it on the 0G behind me. That's Chris with a K and not Chris with a C's fault. Gotcha. I see. Deflect, deflect, deflect. All right, give me 1 second because, like I said, I cannot, for the life of me, find that printed part, and I'm going to need to get that diffuser going. It always helps to have a few extra plates. We've got a satin sheet. We've got the original I3 style, the Mark IV style. This one is a nylon sheet. Got a couple of the BQ sheets. So it's always good to have a few different sheets and different sheets for different types of material, especially if you're dealing with engineering materials. Let me reach in here and grab my clear PETG. I do all of my diffusers in clear PETG. I haven't had any problems with clear PETG, like causing an issue in a tool head. So now, is this wet PETG? Probably. I'm going to say it's probably been out for a bit. Oh. And it helps to have the printer turned on too. It works better that way. It's going to do its thing over there. Do I have Prusa slicer? I do. Do I have my clear profile over here? That's going to be the that right there tells me everything I need to know. So I need to do that over on the other machine. Sorry, folks, I just want to get this part going. So it should take not a lot of time, but this way, hopefully it gets done in time for us to get there. And if you didn't see the announcement and you have a Prusa printer, they did release new configs. So go and update your Prusa slicer if you have Prusa printers, because the new configs change a couple of things slightly. I think there might even be a firmware as well as the configs, and that will fix some resonant frequency stuff with the user preset. Sorry. There we go. Sorry. So there's at least firmware, or not firmware. There's at least some print profiles, if not a firmware update for the Core 1 to reduce a resonant frequency within the chassis itself. It should not affect print times from what they're saying, but it will reduce some of the frequency, which will cause some VFAs. So, all right, Jabberwocky, STLs. Go through and find the front bodies, front body diffusers with the anything with a T. T stands for translucent in this case on the files. And it's funny, there's an A, an AB, an MC, which is main color, and then A and B are the two other different colors. That's why we have a main color and two other colors here. So you can have up to 3 colors in your tool head. It's a little bit too much for me sometimes, but you know. We're going to slice that. This is going to take all of an hour. And I'm doing 2. There's 2 different types. There's a standard logo and then there's a monster logo. I'm just going to go ahead and do both. Send that over to the printer. And did this complete. We're going to tell it to purge more. Probably what was beeping at me earlier. And the reason I'm purging more is I had run some polypropylene through this nozzle, so I want to make sure that I am getting straight, clear material through, which I am. Right into the print queue. Okay, I promise you we're going to be getting there in just a second. So what else is everybody doing today? 5 hours of design in Tinkercad. That's pretty cool. I don't know why you load PETG and it complains because it's like, well, the file says PET, but I loaded PETG through your interface. Stop yelling at me that you think I loaded PET instead of PETG. Okay. Going back here to our printed parts. We'll go back to this view. 4 walls, top and bottom, so 4 wall thicknesses plus 4 top and bottom. They tell you specifically to use the classic wall generator, turn off arcane, they actually meant arachne, and turn on thin wall detection. Got cooling settings, they've got line width settings. Go ahead and check these line widths. There are a bunch of different. Where's your donuts and your coffee? Did you miss the fact that I said Miss Dragon is in a meeting? And I did not go get coffee. Now, we're going to open this up. Let me actually switch to the overhead camera. See if that's going to be working for us today. Hey, it does, but it doesn't zoom in. So we've got the top and bottom cable with end stops. Oh, yeah, top, bottom, end stop cable and the RGB cable. So those are already made for us and already crimped and everything. Makes life a lot easier. Love the LDO kits for that. There's a makeup bag in this kit. This has been fixed in the next kit revision that I got in. Various machine screws, some heat sets, a whole bunch of bearings, magnets, ECAS fittings, gears, you name it. We've got our Phaetus Conch hotend, which looks exactly like a P1X1 hotend because that's exactly what it is. A 2510 axial fan, our NEMA it's the NEMA 14. It's the 36 standard motor from LDO. Our 3010 high pressure blower fans. We'll have all of our fans over there. The Jabberwocky toolhead kit fasteners. So we've got multiple fastener bags. Oh, look, another set of fasteners. That is fascinating. So I don't know why we have so many different bags of fasteners. Like I said, this was a original batch kit. So there may be some new stuff. Or the packaging in the next one that we do might be a little bit different. Hey, thanks for the follow, Low Expectations. That hotend is going in your Sunlu 8S Superfly. Yeah, they're really good hotends. I have clogged the 2 beta units I have in, so I've got to fix those and get them back on the line. But right now, my Bamboo X1Cs are back to running their stock hotends. So we've got a bunch of heat set inserts and various screws in the bottom that you cannot see. So we'll jump back over here. You'll see things like M2x16 button head screw. There's one off. There's a bunch of other one-offs through here. I would say that when you're dealing and wanting to self-source, having all these one-offs really, really sucks. Stop, camera. Stop. Actually, I will zoom you in a bit. But I also want to make sure that you stop doing hand gestures and stuff. Because you can't buy just one screw at a time. So unless somebody's providing a full bomb set, screw set like this, it becomes very painful because you're buying M3x20 socket head cap screws at 100. And M320 socket head cap screw, there's one that you need for this. Right? Now I have most of this stuff in spades. That's no big deal. But for somebody relatively new, like low expectations, who just got into 3D printing in the last couple of weeks, you know, this is why kits are really good when you have a bomb like this. And when I was working on the auto eject project as they were finalizing their Kickstarter, that was one of the big things that we were doing. Was we went through several iterations of printable parts to reduce the overall number and types of screws. So there was several M4 hardware pieces where you needed like 3 different sizes, but you only needed like 1 or 2 of each. We got rid of them and we moved them all to M5s and standardized the length. Right? That's this type of stuff that I'm talking about. Now, on a tool head, you may not be able to get away with that because you're trying to get the most compact. But that's just something I look at when I start seeing a bomb that has a bunch of one-off screw sizes. But I'm going to assume we've got everything we need in the bomb here. And if we need something else, I'm good. We've got our Nitehawk tool board, the 2510 axial fan, the 2 blower fans, the pre-wired end stops, and LEDs, and the Phaetus hotend Conch. Yep, and the motor. So I think we're good with all of the electronics. Now we're going to get into our extruder assembly. Yeah, low expectations. 3D printing is an interesting hobby, and it can be used so much, like for RC, battle bots, drones, where you're looking for RC drones or RC cars, trucks, rally racers, what have you. Definitely a good hobby to get in, where you can print parts rather than having to wait on them. You're super excited to do some builds, but the Sunlu S8 with a hermit crab quick change with the H2 as well. Okay, were you able to get a hermit crab that was not a CAN bus? Free heathen? You got a Bamboo A1 Mini. Very solid choice. Yeah, very solid choice. I will tell you that I've got 2 Bamboos. I've got a 5 Prusa Mark IIIs. Some were self-build, some were purchased secondhand. All of my Mark IIIs are over at Evil Diesel's house, and they're all Mark III S or Mark III S pluses. I've got a Prusa Mark IV, a Core 1, and a Prusa Mini here at my house. Actually, the Prusa Mini is at Ecovate. You'd have to look. You have a ton of parts just sitting around just to build with. Okay, the reason I ask Free Heathen is I've got a hermit crab I can send you, but it's CAN bus. So it's a little bit more to deal with than the regular one, but I think the only ones that you're finding lately are going to be the CAN bus. I'm just saying I've got some that I can send you. So at this stage we have all the prerequisites to do the build, other than the clear diffuser parts, which are printing right now. We do have the Fusion CAD open and the step file open so that we can take a look at it. And we're going to start by doing all of the heat sets. And I like that they're going to go through. I think we do all of the heat sets throughout the build, or maybe not. No, I thought we did. That was the Micron that goes through and does all the heat set parts first. Oh yeah, cool for Ethan. It was a micron that we go through and do the all the heat sets through the entire build first. Okay, so we're going to grab our heat press, and I will say I did build my fracks down at Ecovate over the Saturday for the when we were sitting there doing the buy-sell trade day. So I do have a fracks built. It's downstairs, so I will need to bring that up here at some point and get it connected in. Okay. So we're going to get this start warming up, this being our heat set press right over here. And I think I'm just going to open up all of the packages and pull out all the little baggies. So we're going to be looking for some heat set inserts. There's a couple. I have no idea. There's a few here. More heat sets. Things go the way they normally do. We're going to have quite a bunch of leftovers here. Here's our slide in nuts, our blades, our ECAS fittings. I'll set those up over there for now. Some magnets. What do we do with magnets? We always put them right there on the bench so they don't go anywhere. Bunch of different bearings. Gears, more gears. We'll go over here next to the motor. Dowel pens. I think we'll leave those up there. There's a few more heat sets over here. So we've got a few heat sets. Hey, Monlight, how's it going? So I'm just trying to get all of our heat sets out so that they'll be available. I tend to keep a bunch of these, but I now have a full up stock of all kinds of different shapes and sizes. So unless I start getting into some weird wonky stuff, I won't need those. By weird wonky stuff, I'm talking about selling a bunch of stuff. Okay, so this is the part we're going to work with. I can tell you that there's a bunch of print in place parts that we'll have to snap out of here at some point. Yeah, like maybe now. We'll grab our little pry bar. This bottom piece right here, as you can see, is a print place support. So we'll just try and lever that off. This piece right here looks like a print and place support as well. So we'll yeet that off. Trying not to stab ourselves with the screwdriver and bleed on our parts right off the bat. Okay. And there's one piece right down here at the bottom. So we'll need to yeet that out as well. And when you get these print and place supports off, you want to make sure that you've got all of it off. And if you need to do a little bit of filing after the fact, then do a little bit of filing. Because once again, you want to make sure that your parts are nice and smooth. where they're like adjoining pieces. Okay, and now we're going to come in, we're going to put a heat set insert right there. And then on the back side, we'll do the back side of this piece. No, that is this piece. We'll do one up here and one over here in the side. And you can see that there's another print in place piece in here that we'll have to pop out. And these are designed in supports, so they should come out relatively easy. Just got to make sure that you get them all the way off. And if your supports, oh wow, what happened? We got some height for Modlight. There we go. How's it going there, Modlight? We are working on the Jabberwocky. Wonky for a Jabberwocky. Yep. You're buying an Ender 3 and going to be building an Ender 3 Engie if you can find the part kit. I know that there is a part kit that I think it's a FISEC kit, and you can get it from Fabrico. I don't know much more beyond that. I was supposed to get one of those kits, and I have not been able to get with Hector to solidify a ship date for any of that. So I know he's a busy guy, and I'm trying not to be a pest. So okay, so those two are done. Let's go ahead and do some heat set inserts. Like I said, I've got a bunch of different bags. They're all M3 by 5 by 4 heat sets, so it doesn't matter which one I use first. It just matters that we put the right ones in the right place. So once again, the first one's going right there. So we'll that one lined up. And you guys know me, I get it close and then I finish off on a solid surface to make sure that I get it flush in the part. So first one right there. And then the other one goes in on the back side. There's two, one at each side, or one at each end of the part, I should say. And especially on a part like this where it doesn't really sit flat, get it close and press it home so it winds up being nice and flush there. There's the one here and one over there for that part. You don't want to bleed on the parts. We'll save that for later. Exactly. You have a Pi 4, you're buying, was wondering if I look at the Ender 3 power supply and get down converter going from the power supply voltage down to 5 volt, whatever the Pi needs. Yes. Let me show you what I normally use. I think it doesn't matter. One of these. You can get the Tobsun, or yeah, I think they're all Tobsun, Tobsun. Just make sure you're getting the right one that takes 12 or 24 volt and down converts it to 5 volt at 10 amp or more, because this way you can use it to not only run your power for your Raspberry Pi through the GPIO connection, but you would also have enough headroom here for any devices that you're plugging in. So like a Raspberry Pi 4 needs a 2.5 amp power supply or a 3 amp power supply. And that's before you plug anything into it. If you start plugging like a Nitehawk toolhead board or cameras or whatever, it's going to pull power as well. So you need the additional headroom that a 10 or 12 amp converter like this would provide. You could do a full LRS, LRS 25 5, which is a 25 watt 5 volt power supply, which will get you 5 amps. But this is what I use on the V0s. This was actually something that was spec'd for a V0. So that's what I tend to use. Right, once again, 12, 24 volt to 5 volt, 10 amp. It's like $10 on Amazon. So that's my preference. You can do the full LRS power supply if you have a bigger system. Cool. Cool. Okay, so now we need to take this gray part again, and let me see about zooming. Ooh. Zoom you guys in a little bit more, and then I'll have to figure out the best angle here. Okay, and we're going to have to put in some of our slide-in M3 nuts here. These are the LDO T-nuts. Get a few of these out. And these are kind of flat on one edge and have a kind of weird. It's a flat on one side, on the bottom side down here, and then the top edge has chamfered edges. So, and they're rectangle, not square. So there's one that comes in from the side here. Oh, come on, you get started. There we go. And you'll want to make sure that these line up with the hole. So use a screwdriver or something to make sure that they're pushed in all the way and align with the hole on the inside. Otherwise, you're going to have a hard time when you go to do your screws. So one from the right side, one from the top. Yep, fancy. And a pain that took us, apparently, to get it started. All right, big fingers, small nuts, and slots. Not a good combination. Here we go. Again, take time, try not to bleed on your parts. Okay, so one from the side, one from the top. We need to have one that comes in through the front face here. That one goes in pretty easily, but it's a very deep hole. That go all the way in? I think it does. Very good. Pushed it all the way in and then proceeded to pull it back out and throw it on the floor somewhere. Where'd you go? I miss you so. All right. We will put a new one in there. And be careful with the item that you're using, because pushing that in there, I did get a stress riser there. Should be fine, but and I'm going to hope that there is an extra yeah. That one goes there. There's one that comes up from the bottom and goes up that way. Yeah. And this is now loose in there. So this is the one I think that tells us to be careful of, that we don't yeet this one out. 1, 2, 3, 4 on that side. And it does say, note, the T-nut used for the guidler can be loose initially or over time. It's recommended that during the build, 3 pieces of 1.75 filament be used to stuff the hole to keep the nut in place. Cut the ends of the filament flush and it will be securely held in place by the motor mount. So it's talking about this one right here, which is going to be the guidler, being loose. So it wants us to stuff that hole with some filament. It's a gray part, so we'll grab our Galaxy Gray over here and we'll cut some off and stuff the hole. Hold on a second. What happened here? Holy crud. I've got a blob of death going. Not good. I have no idea what happened there, but that is not good. Sorry, folks, bear with me. Come on. Line up. Go through hole. There we go. Yeah, this yeeted, and I did not realize that this is doing blob of death stuff on me. Come on. No. No blobby of death on this beautiful new hot end. Oh. Sorry, folks, I'm going to have to work this real fast because this is, one, a brand new hot end, and two, a, whoops, a not inexpensive hot end. So please bear with me momentarily as I try and solve this issue. I'm going to be reprinting a duct as well. Hmm. Main blob done. Melted some of the whatchamacallit, the duct. Trying to be careful as we have a beacon probe and a PT-1000 under here. We yeet that PT1000 wire. That's going to be a bad day. Oh. Well, dang. Guess that's what I get for not keeping an eye on a print on a brand new printer, huh? So it did yeet the print and proceeded to go all Blobicus Max on us. I'm going to have to cry over that a little bit later because I'm going to have to take that hot end completely back apart and reprint a couple of parts. But yeah, there's the blob. And yeah, that's wow. Well, maybe I will be working from home tomorrow because I'll have to take that whole thing apart, and I'm literally going to have to take the hot end itself apart to clean that. Well, that sucks. So it was saying to, I think, put filament down in here. Put like 3 little pieces of filament down in there to keep it locked in place, basically just wedging it in there. Doesn't feel very wedged, but we'll go with it. So just put 3 pieces of filament in there like that. Try and hold that in place. We're going to install the MR84ZZ bearing. So we had a few different bearing types back there. Bearing types, yes. MR63, MR82, MR84ZZ bearing. We're going to put this into the mid-body using the printed tool. Oh, thank you, Free Heathen. Yeah, that is a healthy blob right there, and it's going to be fun. We'll go with that to get that cleaned up. So what we're going to do here is we're going to install this bearing into the body using the printed tool. The tool is designed to apply even pressure and prevent the bearing from being inserted further than necessary. Temporarily use any full-threaded M3x35. Do we have an M3 by 35 in here? These are M3 by 35s, but they are a, whoops, they're a shoulder variety. They are not fully threaded, so we cannot use those. If the other stack has a M3 by 35 in it. Does, but it's a it's another shoulder style. Not to worry. I've got M3 by 35 standard. At least I think I do. Yeah, there's them. Okay, so this is kind of the difference, right? This one is a shoulder bolt, right? So you see it, the threads don't go all the way up, but you've got a piece right up here that's not threaded. Then you've got this one that's threaded all the way up. This is the one we want to use. The shoulder bolt style will give you problems. Okay, so we're going to have this piece and this piece. So we're going to install the head of the bolt. So our M3 by 35 is going to go through this little spacer disc piece. Which will come up on the end part here. Our bearing will go in. Then we'll get our bearing set tool. And I'm actually going to see if I can get this to start to line up. Bearing set tool, and the bearing set tool has a spot for a, whoop, darn it, an M3 nut on one end. So we'll grab one of the M3 nuts. Can I make the camera window bigger? I can. We'll do it this way. And I'm going to sit down and cry in my soul a little bit. We're going to just get this in there and get the screw started in that nut. And I'm just going to try and get everything lined up. Because you don't want to start pulling that bearing in if it's not aligned properly, because you're just going to put a lot of pressure on the bearing. What I'm doing is I'm just kind of wiggling it a little bit to make sure that it's in the right spot, so that when there's kind of what we've got. We've got our screw, the spacer, the bearings right down in there. this other spacer with the nut, and I'm wiggling it just a little bit to make sure that that spacer is seated. Now as I go to apply pressure by turning the screw, you're going to see the bearing, if I can get a light right, you'll see the bearing get pulled down in there. No washers. We have basically a printed washer right here on this side, and then this big printed spacer. And we're just pulling that down into position. And once installed, it should protrude just slightly. So I'm kind of giving it some ugga-dugga until I feel it go. And when I say ugga-dugga, I mean I'm turning until I feel that resistance change. And that's as far as I'm going. And I'm going to go ahead and back my screw out, because the bearing is not going to be flush from the inside. And in fact, my bearing is not flush at all based on that first round, right? Whoops. It is not flush at all. It is cattywampus. So we're going to have to work that again. Normally I would do a M5 bolt and nut with a washer on the other side, and I would do it that way. And that kind of ensures that you're getting a straight shot a little bit as well. Yeah, and this keeps flipping out or going in there at an angle. Yeah, I'm kind of not liking that because it's not going in straight. And that is not 5mm, is it? That is what? MR6. What was that? MR84ZZ. So that should be a 4mm shaft, right? 8 on the outside, 4 on the inside. I know I have M4 hardware around here. Let me find it. I need to find my M4 kit. Which is downstairs and in the truck, isn't it? Of course it is. No M4 there, no M4 there. M4 by 6, but no M4 hardware in that. Pretty sure. Those might be M4 nuts. We get lucky. Not that lucky. Need something longer than an M4 by 6. Like I said, I know I have M4 hardware. I just realized it is downstairs and in the truck. All right, folks, I'm going to put you on a be right back screen, and I will be right back. I'm going to mute the mic, and I'm going to run downstairs and grab that M4 hardware kit out of the truck so that we can get this seated right. I'm just not liking the fact that this is not seating. Well, it's not seating straight. And now I'm wondering if we go the opposite direction, if that will help the cause in any way. Let me try that. And if this doesn't work to straighten it out, then I will go down and get it out of the truck. What I'm doing is running the screw the opposite direction. And what that does is give me a longer straight line here because this is now flat up against the back. Because going the other way, it allows it to get cattywampus and not line up. So I'm hoping that this may straighten out that bearing and pull it in. And I think it did. And hold the printed part a little bit as I apply a tiny bit more force. Nope, still cattywampus. So what the ever-loving heck? Is this like a print tolerance issue for me, or? Because normally I don't have issues getting these bearings to go in there and pop down in there in a correct manner. Let me see if I can't relieve that edge a little bit of the material that was getting pushed down in there. Still seems like it wants to pull in cattywampus. Go with the, how's your day going? My day's going great. My bearings aren't going in flush. My printer yeeted itself. The new printer yeeted itself. It's turning into a great day. I'm thinking that might have just done it. Let's hope. Still a slight angle. So I'm going to do this. I'm going to put that there. Put this. Okay, and we're back. So we'll come back here to the side here. And looking from the back, we're trying to make sure that that bearing is seated flat and flush all the way around the edge. And it appears to be now. So we're good. I put my 3 little slivers of filament back in here to try and hold that, keep that from eating itself. All right, so that was painful. That was supposed to be very quick. Next, we're going to insert the M4x18 metal dowel, the LDO peaks sleeve bearing, and the non-threaded orbiter gear, and place the 8mm by 0.5 shim around the bearing. There was a lot of words there. Okay, so we're going to need to put some of these in the same bag. I need a 8mm by 0.5mm shim, 8mm by 11 by 0.5mm shim washer. So we'll grab one of these. This goes around our bearing. So I'll have one of those. We'll have the IGUS peak sleeve. And we'll have one of the LDO gears. Non-threaded gear. Non-threaded gear. I don't know what it means by non-threaded gear, but you know, we've got gear here, we've got some knurling here. The only gears I can tell, and we need a M4x18 dowel pin. M4x18 dowel pin. So it's just coming in from the back side. Just going to do it from the front. Try to as I drop it. Are they both hobbed? Yes, they are both the same. They are called Orbiter non-threaded gear. And they both are hobbed. So, don't know. Don't know. Okay, so we've got our pin in there. So not straight. Hey, Waters, how's it going? We are having a grand old time. And I am now wondering if I just have some really, really crappy print tolerances on my gear, because I did get my gear in there, but it looked like it was sitting flush, but it's in fact not, because there is a chunk of filament that was pushed down to the base. And if I get the excess material out, like, I still need the bearing to be tight in that hole, but I do need to ensure that it's straight down in that hole as well. Does this mean we aren't putting a Jabberwocky on the IR3V2? I was not planning on putting a Jabberwocky on the IR3V2. Were you? That had not been communicated to me. I do not believe the Jabberwocky will go there because of the angles. But yeah, this is trying to get this bearing and straight flush and all the way down has been the bane of my existence right now. Yeah. Okay, that's good. Dowel pen in. We've got the peak sleeve. It talks about the non-threaded bearing and then the washer, and it talks about the washer last, but the washer does have to go in around the bearing. So that goes on around the peak sleeve. And of course, that's going to be a very, very tight fit as well. There we go. And the hobbed gearing side versus the standard gearing goes in. So we've got our dowel, our sleeve. There's the washer partially way down. We'll take this and push it down over the sleeve. Push that bearing all the way down to the bottom. And our hobbed gear is now lining up with the filament path. Perfect, perfect. Oh crap, did we did we make progress? Okay, so before I forget, I'm going to take this little doodad and put it back down in there. Here's one of the 3 pieces of filament that are used to hold that in place. Don't know where the other ones went. They're probably down here on the floor. You missed all the excitement waters. I don't think I'm going to come and visit you tomorrow because I now have a task. We blobbed hard on the hot end. And I think you know what hot end I have in there, the hot end that I cannot show. And I at least have to reprint the cooling duct because that melted. And yeah, I've got to finish taking the tool head apart to dig all of the excess filament out of it. The problem is I can't show it off, and I have to take the tool head apart, and I don't know if I'm going to get the tool head apart tonight. So next, take the motor mount, which is this piece with that slotted area in it, and we're going to install the compound drive gear, the integrated 4417 drive gear. So this gear. And we'll insert another M4 by 18 dowel. 18 or 16? Okay, that says M4 by 18. That says M4 by 18. I've got an 18 and a 16. I've got an 18 and a 16. Make sure that these were all screws and no other dowels. Yep, that one all screws. This one all screws. All right, so one's 16 and one's 18. This ought to be great. The other bearing is going to go in this front depression right here. And it talks about installing it the same way. And now's where I'm going to probably need to go and look at that CAD. Hey, Timor, how's it going? Let's take a look at the CAD here. We're going to need to look at this is the extruder stuff. So can I, find the front cover. tool head and that, and just get to the extruder. Come around to the back, and can I isolate just that? M4 by 18. Sweet. So M4 by 18 on the big gear. And you see that it highlighted the other one over here. Oh. So I'm clicking this one right here. And you'll notice that it highlights the other one down here. And they're both M418. Actually, that isn't it. So that's the M4 by 18. I come in here and hide a few things. Nothing like leaving the tooling in place in the CAD. That helps. Yeah, it says they're both M4 by 18. I have an M4 by 18 and an M4 by 16. Ay. Oh. This ought to be fun. So that's now pushed in from front to back. It just clears the top. We got rotation going there. Try and push that gear up some so it rotates a lot easier now. So it's not right up against the back. We need to press in our bearing from the front up here. And that went in a lot easier, and you'll notice that we've got just the hint of a lip there. And that's where we're going to put our other washer at. Okay, and so what's going to happen is there's that little depression right there. That's where the other M4 by 18 would fit into. And this is going to go into that bearing. So hopefully when it's all said and done, these are good, and this isn't truly an M4 by 16 there and 18 on the other side. Next, attach the mid-body and motor mount, ensuring the gears are properly aligned. Use 2 stainless steel M3 by 10 button head cap screws. So we're going to take these 2 pieces. We're going to make sure that all of our M3 inserts are still in there and lined up, which they appear to be. So I'm going to hold this one up like this, hold this one up like this, and we'll mate them together. Try to mate them together, get them lined up. Just doing the wiggle, 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 shake. Okay, so we wiggle shaked everything together. There's a little, there's like a little nub on the front of the gray piece that aligns here. We've got a step so that it aligns there. Everything is aligning here with another step down here to help line it and lock that in. And as you can see here, when I move this, the lower gear will move as well if I had some better lighting. God, where's my, oh. Better lighting position. Move big gear, small gear moves as well. So everything's moving, and we're going to come in with a couple of M3 by 10 button head screws at the top and the bottom here to secure this in place. M3 by 10 button head. Two-piece M3 by 10. Well, I was having bed adhesion, and I, wow, words. So I was having some bed adhesion. I did take the bed down last night and wash it with Dawn, and it was adhering perfectly well this morning when I started that print before I left for the office. However, as we can now see, that print is has detached and created a blob, which sucks. Okay. Everything fitting together, everything moving nicely. There we go. Okay, so we've got, still got good movement here. I can move the big wheel and the small wheel inside turns, so that's good. Motor's coming in from this side, that's flush. Now, this pin did push out a little bit. It is no longer flush, right? It's sticking out a little bit. So, I think this pin, which is the one that goes through the non-threaded gear, should be the 16, and I should be swapping these two pins around. So we'll see if we can't get that done. Hey, Evil Diesel, how's it going, brother? We're living a dream. So the 0G, we had an issue. So later on after a stream, I will be taking that toolhead apart and then spending time trying to get all the filament out of the heat sink in that part. And right now what I'm realizing is that shouldn't be an issue. Why did that get pushed through? We should be good, guys. I can now look at this and get this put back in the right way. Yeah. Yeah, no, we're good. We're good. No need to disassemble. Yeah, go big or go home. I would have preferred not going that big though, because I may have an issue now where I have to dig that heater and PT1000 thermistor out and swap those as well, which is just maintenance I don't want to do this early in the game. All right, so there's our motor. We want to put an ECAS fitting in there. Yay! We love ECAS fittings, don't we? So we're going to take the little rubber grommet piece off. Throw that away. We need to put the blue thingy in. We're going to use our handy dandy Wiki Wiki. These things. Makes our life easier. Especially if you get them to the right size. Yeah, well, it is what it is. Our Nippics are pretty good at getting these in there. So we got that in there. Now we're going to take this and we'll see if we can't get that embedded down in there. Spidey! Yeah, no, it'll be great. And no, it's trying to get me to bring it down there and use the hot end reflow, and I'm like, yeah, I don't know. Because once again, I'm under an NDA on that hot end. Next, we'll move on to the assembly of the Guidler. Begin by inserting the LDO peak sleeve bearing into the second non-threaded orbiter gear. Second gear. LDO peak sleeve bearing. I only had one of those. Whoop, 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 whoop. Never opened the makeup bag. Never open the makeup bag. There's a few more magnets. Hey, look, there's an M4x18 dowel that I just dropped on the floor. Some more Capricorn XF PTFE. And a few more other things. Okay. So who was the person that didn't tell me to look in the makeup bag for the part that I was just looking for? And now it's going to tell me to use the M4x16 dowel for this. So this is where we will now have to go and take this back apart and get the M4x16 out and put the 18 in and then use the 16 in the appropriate spot. Yay! Rework. Oh, you meant borrow the reflow station, not break the NDA, show it off. Well, that would be good. That's something that can be done. But I do have a heat gun sitting right over there that I can use. Slap a silicone mat up here and to protect my nice surface here, and then hit it with a heat gun. So now let's see if I can push this pin out without hurting myself in the process. Ow. Well, pin's out. So again, that's the M4x16. We're going to put the M4x18 pin in. Get that pin lined up, and I'm just going to use the flat of my pliers, apply a little bit of oomph, and now that's nice and flush with the edge, and our plastic gear here spins freely. Now we're going to get this line back up on there. Seriously. Right, you should be going into that depression just fine and locking in. Why are you being stupid on me right now? And pushing out the back. That's more my issue, is it's pushing out through the back. And I don't want it pushing out through the back because I have a feeling it needs to be flush. Just relieve that pocket edge just a little bit. we'll make progress at some point. The good news is when we go to do the second one of these, we'll know where some of these little glitch points are. Okay. The Geitler assembly. This piece, we'll need this piece. The M4x16 pin that we just dug out of the other one. That piece, our peak sleeve. So we'll put this down in there, this down in there, and well, that there. Make it all line up. This down through the top. Make sure that spins freely. And this only goes in one way. If you try and put it in the other way, you'll notice that those tolerances are real close. So it only goes in from this side. So it has to come in through the flat side of the part, line it up, push your pin through. And now we're going to put in, we've got the flat side of the part here with a little notch at the top. And this is the side that we're bringing our N3x6 flathead cap screw through. And this is basically your anti-squish thingamajig. And as noted, follows are free. So if you're out there and want to, please give me a follow. That tool I think we're done with. So we're going to grab this M3x6, which is going to take a 2mm driver. We're going to tighten it until it sits flush with the surface of the guidler. Okay. So that's super weird because their guidler their drawing's cattywampus. So what I'm looking at here, I'm going to switch view real fast. Okay, so looking at this piece, you'll see that the one side here has this indented piece, right? And if we turn that sideways, you'll see that it's flush on this side, the round out goes on the right, and then this little indentation at the top is there. And this part of the print is 100% flat and flush, yet looking at this, it looks different. And maybe it's just the way the angle of this looks. The cutout on the print might be different. But we're going to run this in, cutting threads in plastic from this side. We're just going to run that in all the way like that. So what this piece is this is going to be the anti-squish. So if you notice here, that's the edge of the, or the threads of the screw sticking out here. And what this gets used for, the screw will later be used to adjust the grip. So it will be used to back off the tension some. Hey, Polymaker 3D rating in with 87 viewers. Hey, everybody from Polymaker. Welcome on in. We're going to switch over to here and welcome everybody in. So welcome in, Raiders. My name's Digital Dragon, otherwise known as Luke. I'm a 3D printing variety streamer here on Twitch. What that means is we do everything from unboxings like the X1Cs here, Prusa Mark IV, to full-up printer builds and beta testing like the box turtles back there. So welcome on in, Raiders. Let's see, we've got Korea Ricebox, Jabberwocky Designs, welcome in, Maker Viking. Thank you for the follow, Lone Sniper and Barking Cauldron and Zal Shizzy. Welcome in. Yep, it is a raid. Thank you, thank you, thank you. Welcome in, everybody. Who else is here? Da Vinci, welcome in. Tech Jeeper, hey, how's it going? Stephen Poole. The Pez Liz. Hey, Liz, how's it going? Kenneth D, welcome in. And is that Palms 3D? Welcome in. Good evening, DMAT. Hey, yeah. So tonight, we were printing, and I had a print going on behind me, and I just happened to turn around to look at the status and realized that something was amiss. This is not all of the blob that I pulled off. I'm going to have to take the hot end off and get the rest of this out of the heat sink and see how many parts I'm going to have to reprint and see if I just trashed a brand new heater and PT1000 thermistor. So not happy there. I mean, it happens, but still not happy. Obviously, the print popped off the bed, so that kind of sucks. Hey, Tin Talon, welcome in. And the rest of what we've been working on is building the Jabberwocky here. I say that, and I do this big display out here, and you can't see most of it because I'm zoomed way in, but we've got all of our Jabberwocky parts laid out here, and we're slowly going through the build. I've got 2 Jabberwockies. This was a kit that was given to me by KB3D Chris out at Murph. And so we're going ahead and building this one. And then yesterday or the day before, Tuesday it was, so that would be the day before, out of the blue, I had a package show up that I had no clue, like, I don't know what this package is. And then it shows up and I see the LDO tape and it's from Jason. And I'm like, huh. And the shape looked very familiar. So I now have a second Jabberwocky that we'll be putting together. So this is dry run for the next Jabberwocky. And the color scheme here is Bamboo Black ASA. This is Ambrosia, what was it, Galaxy Gray, and the blue or purple, whichever it is the Galactic Midnight Meteorite. So yeah, that's the color scheme for this particular build. It goes with no printer color scheme that I currently have in place. Don't know which printer we're going to put it on, but it'll go on a printer somewhere. So now where we're at is we're going to attach the guidler to the extruder using an M3x20 socket head cap screw. And I've got like 3 different sets of hardware that came with this kit. This was an early kit, so it had a makeup bag. Which was great because there was a M4x18 and an M4x16 in the main kit, but first 2 pins it called for were M4x18. So we used one of them, and then I remembered the makeup bag when I was looking for the needed 3rd one for the guidler here. So this is going to lay in on this side. That will lay in. We'll make sure that our gears are meshing, and when I move the big gear back here, you should see that gear moving. Kind of hard to see. Let's zoom you guys back in some. So when I move the big gear on this side, you should see that gear moving, which is the outer idler gear, which means all the gears are moving together. We're going to put an M3x20 socket head screw from this side, and it's going to go down and through that guidler, hopefully. It will. I just probably needed to clear out that hole a little bit. Hey Clown Hammer, how's it going? So once again, I'm going to screw this in until I feel very lightly with my fingers until I feel a difference in the tension. Because once again, this needs to be able to pivot. And preferably, that's pretty interesting. Yep, that's good. So that's there. The reason I say that's very interesting is I'm going to pull this out. So that's not a full enclosure. So you should be able to pop this out if you're having to dig in for a filament issue. Just make sure your gears get lined back up, which it is. Now we're going to put our tensioner in here. Where did I put the tensioner arm? Here's the tensioner arm. Now install the tensioner which will screw into the LDO T-nut we put in earlier. And I believe this is the one that we captured with the 3 little pieces of PTFE. And normally what I do on my tension is I go all the way in, just finger tight all the way in. And then I undo it 1 full and complete turn. That gives me my very first initial tension. And then we'll back it off from there based on how much teeth marks we're getting. Now we're going to install an F682XZZ bearing. This is a small flanged bearing. And once again, this is a small flange bearing. And this is interesting. So in the bottom here, we have this little swoop. The flange sits in through the black piece, and then we'll slide it into the gap and move it all the way up to where it covers the filament hole. You see all the way through it? Now that gives us a metal surface, and you'll see a channel here. That's for the filament cutter. So that provides a metal surface that will capture the filament and give us a shearing spot. And on the mating surface of the tool head, there will be another one like that that gets added in. So I thought that was pretty neat that it pops into the channel and gets pushed down into the channel there. And that's the extruder assembly. So this is our full extruder right here. Now we're going to move on to the front cover assembly. And this is where we'll get into a couple of other pieces. We'll have this little printed piece here. We'll need our LED. Just pull all of that out, because this is our LEDs and our end stops. So LEDs, end stops. And you'll see that we've got we've got 2 LEDs together on a small board. And then we've got a single LED with a male pins, female connector, right? This is what we want. And we're going to put our LED in here with the LED portion facing this open gap. Now where the wire goes, I would assume that these will slide in. Whoops. Slide that in. Maybe. Go in there. There we go. So that's now slid in. Our wire's coming up through the top because that's the only little gap that we have for some wire management. So I'm going to assume that these wires will, let me see. Nope. maybe they'll bend forward there, are end stops. We've got 2 end stops. Top is the yellow and black, and bottom is the blue, so we know which way that they go. They're going to get mounted on top of and below our light with the legs coming out towards the light. And the way these work, pins are facing the same side as the NeoPixel LED. They screw into place with M2x10 socket head cap screws. The depression on the switches must align with the latch side of the extruder. Look at the image following for reference. So we need to make sure when we install these that we're going to look at the way these little wings go down. So this is the top where our wire comes up. That's going to be where our top one mounts. And our top one, once again, was the yellow and black wire. And we need to mount it in such a way. Let me grab my M2x10 screws. We're going to need to mount these in such a way that the plunger is on the left side of the piece. So there it is, with the top being where our wire comes out. We'll grab the top one, which once again is the yellow and black wire. And our plunger needs to go on that side. So I'm going to feed that wire through. So you know what I'm going to do? I'm going to make my life easier. I'm going to cut these center pins out. I'm going to cut the center pin out and cut it flush with the case. Because we don't need those center pins. And that'll make it a little bit easier. So once again, the top's coming up, the yellow and black's the top. I'm going to put my wire through there, and this will come down, and the plunger is going to be on the left side based on our diagram. So we now need to screw this in with M2x10. And we're going into plastic here, so no ugga-duggas, we're just bringing it down snug. And once again, this is where you just kind of use your fingertips and you feel for that change, and boom, you're done. Now the bottom one, once again, the plungers need to line up, so however we need to do that, we'll flip that around so that the plungers line up on the same side, and we'll put in the next set of screws. Okay, so there is our completed unit. And if we flip this around, you'll see how our wiring is set up. We can try and keep it nice and out of the way of the LED. Now, we're going to need one of the printed parts that we completed. Oh wait, this has been my day for fails apparently, because that failed. Because why not? Oh. I'm going to try my best not to trip and fall over and hurt myself again. I apparently need to empty my garbage can. What was I coming over here for? Oh, shop towel. We're going to clean that bed and then we're going to try it again. And the part that sucks is that this print takes an hour. So we won't have that. So I'll need to backtrack a little bit down the road. Once again, here's the part that we're going to be mounting things in. We've got a print in place support there that we need to snap out. I love when all but a tiny piece comes out. First attempt at learning. First attempt in learning. Yep. Nah, it's just one of those days when things just don't want to work right. So, it is what it is. We all have those days. So, what would happen is there's a channel in here. Slide the diffuser in. And then this piece with the LED facing the front kind of just goes in right there in that will fit in just like that. And once again, you'll have that diffuser. So from the looks of this, we should be able to route that wire around. I'm going to route that wire right up this side over here of the LED. And the good news is that with that going in there just like that, we should still be able to slide that diffuser up in there once we take this back apart to work on it. There's all of our wires there. So hopefully I don't have to take too much apart to put that piece in once it's done. Next we're going to assemble the filament cutter. So that will be this piece here. Whoops. This piece here. And the tranchette sharp, aka a tool piece. Yeah. Tool piece. It's got words on it and God knows what language. But what we're going to be able to do is take our M4 hobby blade, which we have 5 pieces, so they give us extras, which is cool, because you should swap your cutting blades occasionally. We will need 1. Just 1. And by the way, there's like 7 blades in here. So, LDO for the win. Put those back in there so that we can try not to slice ourselves open on them. Apparently too late. We'll assemble the filament cutter. Begin by installing the blade. Carefully press it into the blade carrier using the blade installation tool. If the blade carrier is printed on a textured plate, it is recommended to sand it lightly to ensure a smooth finish. Well, it was printed on a textured plate, but it's a minor texture. This was printed on one of the Kadive plates. So I don't think it's not like a major texture. So we're going to take our blade. Just going to making sure that we have just a blade and not 2. And the part with the hole, and be careful of where that blade's at. It is extremely sharp. The part with the hole is going in the slot here. We'll start to get that wedged in there. Might have to I'm going to try and get the overhang cleaned up just a tiny bit without once again slicing myself with the X-Acto blade either. You do want this to be a tight fit, but not a stupid, crazy tight fit, or you'll be reprinting this part every time you need to replace a blade. And you can use your tool to cover the sharp end of the blade as you try and push this into your cutter base. Which I got it in there about how far I could clean it with that. And now we're still running into It's slowly going in. So just take your time, wiggle it back and forth. Do not put your finger down at this end, because if it blows through the end of this part, it's going right into your meat mitt. So hold it and then, like I said, push, and I'm just wiggling back and forth, and it's going in little by little. So how's everybody from the raid tonight? You can see that we're starting to get the blade down through that U shape. We want it all the way down to the end. Lots of fun here. Guess I could grab it like this with my pliers so that I'm not getting my hand anywhere near the business end there. Almost there. They should go all the way together, because you'll see the little depressor here. It's still sticking up a little bit because it's not, the thing's not all the way in there. Feels like it's close though. I think that's down in there now. Be careful once again pulling that off. There's your cutter. Looks like a cool build, but it might be a little too expensive for you right now. Yeah, I mean this, it's what, it's $140, I think, for the kit. A little bit more if depending on where you go and get it. I feel like this might still need to go down just a tad bit more, but let's see. We're almost there. Blade fully engaged. So blade fully engaged. Light tap taps. We're going to slide that blade carrier into the cutter arm and secure it using the M2x6 button head cap screw. It can be done later for safety. We're going to do that. I'm going to go ahead and put this on there, and we're just going to leave that there for safety. We'll hold off. Install the N52 magnets into the cutter arm. Our cutter arm is one of these. I don't know why I have two of them printed out. They look to be exactly the same, so don't know why. I say they look exactly the same. The only difference I can see is one has the little divot on here. That's the one I'll use. The other one will be we'll go over there. So we'll use this one. Once again, we can put the blade in, but I'm going to hold off on putting the blade in just yet. We've got a hexagon spot here for our N52 magnets. These are, make sure the polarity opposes, they resist each other like a spring. That of the magnet on the extruder may need a small dab of super glue if it seems loose. We didn't put a magnet in the extruder, did we? I don't think we did. No magnet, no magnet. Because, we missed the magnet down here. Interesting. One of the 6x3 N52 magnets. So we're going to put one of our N63 N52 magnets. Don't drop and break the extruder. It's going to go right down in there where that hexagon place is. Using the countertop to make sure it's fully seated and flush right there. And we've got to remember when we go to put it in with the cutter, that they oppose. So the polarity should be the opposite. Okay, and that magnet's in there now, and they're pushing away from each other. So that's what we want. And I say I was not going to put this in there, but what the hell? Why not? We're going to use a M2x16 button head cap screw. Hey Pete, how's it going? Stay creeping, welcome in. How's it going? So I'm going to say we're on a slow build. M2x16, that's a 1.5 millimeter head. And we're going to make sure when we put this in there, we're going to be coming through this side here, and our downward piece, or the screw hole, is facing downward here when we put this in. So we'll get that hole lined up. And this is just going to go in until it's flush. We did not screw into anything on this piece that I'm holding. It is screwed through the blade holder, and it's just becoming a pivot joint for the blade holder. So I'm just going to work this blade holder around a little bit. Just try and work those mating surfaces together some. But there's that. Now we'll install the filament cutter, the extruder motor, and the front cover. Start by inserting the M3x12 button head cap screw through the cover and lightly tightening to hold the assembly in place. It's a good time to check the alignment of the sensor pins with the two MR63ZZ bearings. We almost forgot that. So on our extruder housing, the gray portion in these two vertical slots, we need to put the two small bearings. These are the MR3ZZ bearings. We're just going to take said bearing and pop it in the slot. Just like so. M3x12 button head cap screws. M3x12 button head cap screws. Here's one M3x12. Through the cover and lightly tightening to hold the assembly in place. It's a good time to check the alignment of the sensor pins on the bearings. Okay. So we'll need to look down here and see what we're dealing with. So the front cover against the extruder and the M3x12 is at the top. So once again, this front cover we may have to take off in order to slide our piece in here once it's done printing behind us. Should print just fine now, but so we're going to take this, we're going to line this up. I have a feeling all of our wires are going to go right through that channel. So we'll start by sliding these wires in. We'll start by sliding the wires into the channel. lightly tighten. And what I'm going to do is I'm going to take a piece of filament and run it through here and listen to see if my bearing or my clickers get depressed. They are lining up. They are lining up and engaging. Okay, so align the filament cutter and insert the M3 by 40 button head screws. M3 by 40 button head. M3 by 40 button head. All right, sounds good, Waters. Maybe I'll swing by and get your hot end reflow thing. Okay, so this is going through the front here, and we'll go through the tall arm here. Tighten it just enough to keep it in position. Okay. And tighten enough to keep it in position is basically right through the gray there where you start to see it popping into the heat set insert. So that would be the keep it in position. Okay, so something does not appear right because that is not going to give me a clean filament path. Hmm. All right, we'll take a look at it and we'll figure that out in a minute. Our extruder motor. And it looks like in the picture over here on the right, the whatchamacallit, the wires are coming down to that side. So when we put this in, it's going to go basically in that direction. So we'll line up that motor with the lower side. We'll grab our, which screw is this? The M3x35. $35 will be for the other side. I need a 45. So slightly snug that up. And then on the other side, we'll need the extruder lever lock, which is this little piece right here. Once again, you'll see that that piece is not a full circle. And this is being secured with an M3x35. Just getting it started, and then we'll come in here. Okay, that's slightly tightened. Now we'll be able to rotate this motor still a little bit, and that's what's going to get us removal of the backlash. It does say to remove the tensioner, and that's so that we can get to the mounting screw back here. M3x8. Yes. Yeah, this is a fun little extruder build. There's been some quirks, but I think part of that is this is an early pack that had the makeup as they had changed things in production. So the next one that we do, one will be a little bit more familiar with the whole build process. And then two, we'll have everything kind of laid in there, right? So I'm going to pull this in tight. And I'm going to get this started. And once again, I'm looking for engagement, but not a lot of, I'll say, tension. You want to make sure that there's no backlash. So when you move it from one side to the other, you shouldn't have a you shouldn't have movement before it grips. But like I said, you also don't want to have it so tight that you just induce undue wear on the motor. Okay, that's good. I like that. And once satisfied, fully tighten the two screws, secure it, blah, blah, blah. Recommended to add Loctite to the two motor mount screws so it doesn't come undone. I worry about that because you're going through the plastic to get there. I kind of worry about that. Dang, it's talking about doing the toolhead board again, so I'm going to go ahead and put my tensioner back in, and then we'll start doing the mount for the toolhead board. Once again, we get that tightened down, and then it's one complete full turn. And you could do a half or another full. That gets you a good starting point on your tension. So I'm going to set this down on its front face here. Just going to go ahead and tighten this in so that it's out of the way. Okay, so once the Nitehawk board and the standoffs we're going to use are in the Nitehawk kit itself, the USB adapter board, the Nitehawk board, self-tapping screws, standoffs. Um, just the two knurled standoffs, and there's a couple or three tiny jumpers in there, so be careful that you don't drop those somewhere. We're going to screw these onto the back of the M3 screws that are sticking out from mounting the motor. They're knurled, so you can get a little bit of grip on them, but do not try and ugga-dugga or crank these down. You will snap things. Because you've got a stainless steel screw and an aluminum standoff, you will shear threads and you will snap things. So you can put a little bit of Loctite on the back of these screws when you screw these down, but that might just, once again, I get worried about putting Loctite that close to printed parts. Now we have our toolboard standoff. We'll line this up, and we're going to be screwing through these two depression holes right there. M3x8 socket head, not button head, right? Or nope, button heads. So we'll grab two more of the M3x8 button heads. What is it with me and screws tonight? I guess it's telling me I just need to stop sitting down. Okay. There's our rear toolhead board. Highlighting your messages again. Okay. Next, align the Nitehawk board to the mount and fasten it to place using another two, optionally four M3x8 button head cap screws. These are going to go right into the plastic. Okay, so this is interesting. And I'm wondering if this is just a new rev of the Nitehawk board that does this, because there's two holes, one there, that you put screws in, but you see these little partial holes at the bottom. Those are the other two that you can put in to provide a little bit more stability to the board. So, options. Well, darn you. Apparently the face of this is not as flat as I thought it was. And you will be cutting threads, so I'm not going to go fully down until I get all the screws started. That way I don't have any alignment issues. Because there is a bit of wiggle room there. Once again, we're cutting threads into plastic, so don't ugga-dugga it, because you will strip the threads out, and then you'll be, I don't want to say in a world of hurts, but you might just be reprinting a part. Okay. And there's our toolhead board mounted up. Install the upper strain relief using an M3x12 flathead screw. Okay. M3x12 flathead. And the rounded part here is facing the back of the board. So it's going to slip in from the front to the back. Slip in from the front to the back. Let me flip that around. It doesn't face the back, it faces the front. Why does it face the front? I don't know. Don't overthink it. Just follow the directions. Follow the directions, Luke. And I've got a little bit of overhang there that I need to file down. What do we do with the file? there it is. I know. I'm a goober snot here. I'm like, what is going on? Why is this not fitting? So I did clean the overhang there, but there's a print in place support right there that needs to be popped off. I just kind of did the little round over a little bit on that. Now I bet you this is going to fit in there a lot nicer. Ta-da! Uh, Gently move the filament up and down to get a feel for how easy it is to pass through the system. You can also listen for the click of the sensors. Click of the sensors. I think we got enough filament that we can do that. So filament goes in. All right, we've got the first filament sensor clicky. Second filament sensor clicky. And we're moving through pretty easy, but once again, this is what's getting me right here. Filament's moving easily, except for when I'm starting to get caught up on the blade here. So tension is good. Did just shave a little edge off there. So this may still need to go down in there a little bit further. Dang it. Lower tool assembly. We're going to set this off to the side. We'll figure out our blade here a little bit later. We'll put it right over there so it's out of the way. We're going to get our lower assembly piece, and there is a bunch of material in here that needs to be taken out. Namely, like right here, there is some print and place supports. So that part came out. Looks like there might be some more on this side still. Nope, hold on. Think this through. Not the inside, it's this front edge here. Front edge here that needs to come off. So we'll grab hold of that side and give it a little twisty, twisty, shaky, shaky. There we go. So that came off. There looks like some bits right here and a bit right here that'll come out. And once again, this is all print and place support, so it should pop out decent if you got good tolerances. Okay, and this little piece right here. And what I'm going to do is I'm going to clean this up a little bit more. I'll scrape where I can scrape, and then I'll come in with the file and file it down for a nicer finish. Don't be afraid of filing your parts if you need to. Getting a little bit of excess off of an edge might be the difference between a very nice, good fit and something that's way too tight and not, doesn't move well. Okay, we should be good to go there. Begin by installing the heat set insert in both the shroud body and the conch mount. So it's showing to put a heat set insert right there, but there's a spot for a nut. So I'm going to put the nut in there and not do a heat set insert. Say, getting these ends sometimes are a little bit harder to do than you'd think. Okay. These are zip tie points. So I got that nut in there. And then on the conch piece here, we've got another couple of pieces we need to pop off. Well, that wasn't annoying at all, trying to get the print and place support that went all the way around here and then had these two spots here. Well, we got it all out. Came out pretty darn cleanly, actually. One nub right there. Okay. And we do need to put a heat set down there. That ought to be joyous. Standard heat set tip cannot be used here. Gently press the insert in by using the side of the soldering iron. Take your time to insert the insert. Sinks in evenly and does not tilt. Use the same method to install it on the conch mount. Yep. So we'll get that in place. We'll heat up our heat press. And I'm going to kind of come in from the side. Get it warmed up, and then I'll use the tip of my thing to push down in there if I need to. Getting closer. Trying to be very careful not to melt this top edge here while I'm putting heat into that bottom, or that heat press in the bottom. Almost. So I'm using the back of this as kind of my little hot press to try and get that pressed down on there. Still has a little bit to go. Being a little bit proud still. I don't feel like I'm able to get a really good amount of heat into this part. Until I push it all the way through the part because I wasn't paying attention. Sweet. There we go. Got a little bit of raised plastic around there as we move that through a little bit deeper than it needed to be, but we're good. I'll shave a little bit off the top there. We should still be good. And our clear parts are done. So remind me before we start putting some things together and closing off that piece to stick that in before we forget. Next, we install the two LEDs into our little LED carrier. So we've got our LED carrier right here. And we've got our two LEDs. And it doesn't really say which way they go. Wire routing. Oh, there we go. We install the LEDs to illuminate the hot end, pre-wire NeoPixels in the dual Neo holder to ensure a proper fit. Gently bend the wires at the center so the LEDs can drop cleanly into their designated slots. okay, make sure the shorter wire is positioned on the left of the the cutter side. So shorter wire needs to be on this side. Just trying to see which way this thing goes in. It's going to go in like that. So shorter wire on the left side over here. Shorter wire being this wire. So it's going to go down in there like this. Now, do the wires get routed to each side? It kind of looks like it. Okay, yeah, so each side goes to its own side. And this will get pushed into that slot. Easier said than done. Okay, so sorry, so this is sliding into slots at an angle, right? And you can see that it's very nice and flush at the front, but it did slide in at that obtuse angle there. We've got our boards there. Now these wires route to each side down through the fan channel and kind of up and around like that, I do believe. So I need to make sure that these are fully down in these channels, and that includes these internal wire routing channels like right here. So I have a feeling that the sliding the fans in will help some. So what's the next step? The 2015 is going to be a push fit in the front. I'm trying to get this wire routed down in here. Gently pushing it in there, preferably with fingernail, not with a blade or a sharp object, but we'll use what we can. Hmm. The wire routed down the side, up through the wire gaps, and currently up through the top there. Install the 2510 hot end fan. This is a push fit component. It should be oriented so the wiring exits to the right, aligning with the designated cutout. To the right. To the right, which is this side. Nope, it's got to be off to that side because that's where I've got the gap at. Okay, nothing there that shows me wire routing. All right, so we'll say the right. The right was where the long wires were. I'm going to follow my I'm going to follow my first idea and flip it the other way. We're going to bring it out to that way. Now we need an M3 by 25 socket head cap screw. This becomes the latch down mechanism. It's going to go through the hole right there and then go into the whatchamacallit, the nut that we installed. Hey Nick, how's it going? I did not buy the wireless fan, no. No, did not get the wireless fan model this time. After this, we'll install the DC fans. One blower on each side. Part fan 1, part fan 2. Okay, well that's very reassuring. Wires are the same size, so it does not matter. So part fan 1 will be on this side. Blower needs to be down. So this wire goes on the inside. And we'll track in the gap that way. Apparently there's a lot more room for wire in there than I thought there was. Not sure how much more of this wiring I can shove down in this crevasse. The other wire will come out the backside, which will make life easier. As long as you make sure that your blower fan openings are facing down. That makes your life a lot easier. Once again, I don't know if these go down in the crevasse or not. I'll try and get them there for now. And then install our pretty grill with our little dragon right in the front. Very nice, good press fit in there. Two LDO T-nuts in the conch mount. Ensure the screw holes are properly aligned. Ensure the two sides of wires are pulled out of the conch channel. Eh? Stop playing around. Okay, so there's two spots for nuts right here at the top. So we need to get a couple of more of these little slide in M3 nuts. Need to make sure that these are fully seated so that they line up. Okay, so it says make sure that the wires are out of the conch channel. It'll slide under and outside of the plastic mount. Carefully slide the hot end into position. So what they're saying is normally these wires go up in that channel and a fan mounts right over the top of it. We're going to pull these out of the channel and they're going to go underneath the plastic or out of the plastic. So we've got that done. Which way is this sliding in? Short side this way. Is that the right way? Yes. Trying to figure out where it seems like we're hanging on. Be careful not to move it by that. You will damage your heat break. Make sure you're all the way pushed in and you're lined up. And we're going to put two screws in from this side, and they're going to be M3x16 socket head cap screws. A later edition update was adding M2.5x8 screws to the lower portion of the conch mount. These eliminate the need to use drop-in T-nuts and bottom mounting screws, making them redundant and unnecessary. The two M2.5 screws are also make it much easier to remove the hot end if needed. Oh, so rather than do it at the top, you can just do it at the bottom, basically going through the printed plastic into the fan pieces, making it easier to remove the hot end. The note should probably be up higher because now I've got the nuts in there. Might as well just do it this way. Okay, what is going on? Here we go. So conch hot end installed with the two screws through here. Once again, there are provisions now to put a screw here and here, and 2.5x8 that'll go into the heat sink like the fan normally would. And there's this little notch right here, so I think this is the side it's expecting our wires to go through. And it wants us to put 15mm Bowden tube at the top. We're given two pieces of this, so we'll just grab one of them. Literally just standing there. Oh, that would be why. Take that out, put this here. this slides in. I have a tight fit, but it popped in just like that. Wires are coming over here to the side. And we'll take our Bowden tube and come right down from the top. Use a hex bit to push down on it to make sure it's fully seated. Have a slightly larger hex bit to make sure that we don't deform it when we push down to make sure it's fully seated. We'll now join the extruder with the lower section of the tool head. First slide the ZZ bearing over the 15 millimeter Bowden tube. If it does not fit, ensure the Bowden tube is fully inserted. Well, right now, I can tell you I don't think it's going to fit because the Bowden tube's not fully inserted. And that means that this stuff is not going to go in that slot all the way around like that. Because it's supposed to go into this gap, and that is way too proud for that to slide in. So I've pushed that down in there as far as I can. The hot end seems to be fully seated forward. So that is going to be a problem. Huh. So hot end's not coming out, so that means it is pretty much locked with that PTFE tube. Because we're supposed to take another flange bearing and slide it in there. Like this right here. And that flange bearing is not going to go in there and go over that PTFE. Look at that go. And he just dropped the small, tiny flange bearing. There it is. All right. So I'm going to have to do something. I'm going to have to figure out how to get that tube back out. Luckily, they gave us two. And the question is it actually 15 millimeters or is it long? So that one is 15 millimeters. I don't know if this one is 15 millimeters. And I don't know if I'll be able to actually get it out either. All right, so I got that little piece out. Now let me measure that one. And that's 16 millimeters. So we'll just try to do the other one, which will hopefully be smaller and the appropriate size. Yeah, this one is closer to 16, almost 17. Better. There we go. See, that's how that should be looking. Nice and basically flush at the top of that track. Now we can take our bearing and slide it in there over the little bump. Just like that. And we can take our filament, test that filament path. So filament path is still good. There we go. And we just had to shave off about a millimeter, millimeter and a half of the PTFE tube. So we'll take this one, we'll throw it back in here as the spare. Okay, now we're going to take our tool head with our filament cutter, which, like I said, our filament cutter is still a little worrisome because it's not it's not giving me a clean filament path. It's almost like it is now I wonder if I put that in backwards. I don't think I did. Now there's that. There's this. And it went downwards. Now it just makes me wonder if I still don't have that in just enough. We will pull this back out and we'll see if we can't get that in just a tad bit more. And I kind of don't want you guys to see what I'm about to do, but Can you hear me now? Okay, mics are dying, so how about this? I'm going to go ahead and cut the stream. We're at almost 5 hours anyhow. So thanks everybody for being here. We've got our toolhead built. We've got to deal with the wiring and, well, once again, come up with a printer to actually mount this on. I may see if I can't get the file for the printed stand to mount this on a stand somewhere until I get it mounted into a printer. But I'm going to bounce out of here for now. Saturday we'll be back at it doing something. We will need to, like I said, figure out how to mount this at some point. So yeah, with that being said, let me see if I can find a raid target real fast since we're running on borrowed time on my mic. Trying to see, is zombies up? Yep. I haven't raided into zombie in a hot minute, so that's who we're going to raid into. So, folks, thank you all for being here. I just got the raid started to Zombie Hedgehog. This has been a blast working on this build. I think it's going to get easier when we do the next one, because there will be a next one. And have a good weekend. Enjoy tomorrow, which is Friday. And I will see you all Saturday morning. Bye now. And if you're watching this later on via YouTube, thank you for being here. Sorry this one went long. We had a failed print, blah with death, the whole 9 yards. But we did get our toolhead done. So thanks a lot for being here. If you like what you saw, please be sure to like and subscribe below. Click that bell to be notified of future events. And YouTube is going to be suggesting a new video for you right over there.